Hi everyone, welcome back to the tutorial. Today we are going to talk about the null hypothesis. So for the tutorial, for the hypothesis testing. So from this question, the first sentence, second sentence is just introduction. Well, the main important is we know that the given null hypothesis information and the alternative hypothesis. And in this case, right, the alternative hypothesis very clearly stated that it should be bigger than average 72. And therefore, our null hypothesis in this case is equals or smaller than 72, whereas for our alternative is more than 72. So what is the test statistical for 50 samples per hour? So it's given mean is 75, the standard deviation is 15, and n is 50. So plug everything in, you can get 1.41. And the next one is we find the rejection region. Because the n is more than 50, so we can use this table, the standard normal distribution table, right? Okay, so next, you can find it in your slide or you can find it in ITEL. Okay, so because your rejection ratio is 0.02 and yours is right tail based on the alternative. So what can you do is you have to look at the area under the curve 0.02. So let's find 0.02. It seems like okay, this line is closer. The closer one will be 0.84. Am I right? 0.84. Okay, am I right? No. Oh, sorry. This is 0.02. So 0.02. Right, 0.02. Okay, the closest one would be, oh, sorry. Yeah, 0.2018, which is 2.05, right? And my rejection ratio is because on the right tail, so you have to convert into positive. Therefore, your rejection region is 2.05. Okay, so based on 1C, do the data support the theory? So it's not in the rejection region. So therefore, we are actually fail to reject the null hypothesis. And we support the alternative hypothesis. So for the E part, it's given that we have the new Y, which is 78. Okay, so what is the probability that we will fail to reject the null hypothesis of 1A? It seems like we still using the null hypothesis that the previous one. So we have the 78 minus 72 and all the information above, we have 2.83. So in this case, we are not setting the significant level. Probably we can fix the 2.83 as the line that showing that, oh, the left side of the curve is support the null hypothesis. Okay, if you do that, so 2.83, 2.83, we look at this, okay, and 2.8. So we can move here, 1, 0, 1, 2, 3. It's about 9976.9976. Is another word means we fail to reject, percentage that we fail to reject the statistical, it's 99.76%. Is that okay? So next, suppose that the alternative of interest has been set to alternative is not equal to 72. So we know that our null hypothesis is equals to 72. And in this case, the mean change for the 50 samples, So we can have to find the new test statistic. And don't forget, this is two-tail, right? And if you, okay. So we can refer here now. So we a bit small. And the closest 2.236. So we can have negative and positive because two-tail, right? So we start with the two negative side. And the closest will be 2 point, in between this, probably I divided in here. And don't forget, this is alpha over 2 only. So, and therefore, if you want to find the significant level, you have to times 2. And in this case, we have 0.25. Okay. So what about in this for the G? We change our standard null hypothesis, right? And to 78. And we would like to find the new mean, okay? That fail to reject the null hypothesis if alpha is 0.02. In this case, we given the alpha. In this case, we also have the 78. So first is we convert this, the area into Z, which is changed to 2.05. How to do that? Same thing. 102. 102. 102. Yeah. So this is the closest one. 2.05. Can you see that? The underline is 0.02. Okay. So we have our because we reject, if reject have to be smaller, smaller. So so then we make it as smaller than 2.05, and we solve this out, and then we found that our mean for the 50 samples need to be smaller than 82.35 if we would like to accept the null hypothesis with the new mean of 78. The null hypothesis is 78. Suppose that the alternative hypothesis is still 72. Find the mean that support the null hypothesis given that the significant level is 0.1. Same thing, we have to divide the significant level to 2, right? And then we have the null hypothesis, the sample should be the same, and therefore very quickly we can find our X. Whereas if our sample is smaller than 20, okay, as the case above, then we have to use the t-tail, the t-test table. Okay, so first we fix our null hypothesis equals to 72 because alternative given is not equal to 72. And we quickly do the test statistical, and it's 1.729. All right. Okay. Remember, then we refer to the table. There are two types of table. Okay. One is you can show the two tail, but in this case, I only have one tail. So it means that later you have to times 2. So our DF is 19 because we have 20 samples. And therefore, and we having here is 1.729. You are lucky because it's very straightforward. So your significant level is 0.5. But because of the alternative is not equal to 72, then you have to times 2 because you need to find the alpha. Each of them is alpha over 2. And therefore, your significant level is 1. Okay? Right. Thank you for your time. If you have any question, you can come to me again.